Let's get right to the beginning of this reading. I will say if you're looking at the first page of the reading on transformations, uses, and sources of energy, I'm dropping down to the third paragraph on the front page, and we're going to call that paragraph 1. So if you will, just mark this paragraph 1, and it would be the paragraph at the bottom that begins with the diagram below shows how chemical energy can be released and transformed. Okay, so the idea is to be thinking about as we read this paragraph. So what are energy transformations? What are energy transformations and how do they occur? So let's just get started. The diagram below shows how stored chemical energy can be released and transformed into mechanical energy through burning. The thermal energy, or the heat from burning a substance, can be transformed into mechanical energy, then into electrical energy by power plants in different regions. It is then delivered to local power companies and eventually to our homes, businesses, and public buildings. As this electrical energy enters your home, it can then be transformed into mechanical energy by your household appliances. What other energy transformations occur in your home each day? You can be thinking about that, but get your green colored pencil and let's just get a couple of these things marked. So, transformed, transformation of energy, transformed. Let's just make a little note here. Transformation of energy is when energy changes from one form to another form. So, for example, let's look down at the flow chart at the bottom here. And this is a picture of a basic power plant. So, fire gets created in here. Water boils and creates steam. Steam comes out through here and comes down in through here and turns this turbine, mechanical energy. So we have fire from burning fuel, transforming water, changing states from water to gas. Then this steam, water that's turned to gas, steam comes under pressure and comes into the turbine and creates mechanical energy in the turbine. Well, this turbine is connected to an axle, and that axle is connected to a generator, which also spins, and there are magnets in here and wires which generate electricity. Okay, so we begin with a fuel that we burn. That heats water. That water changes state, becomes steam. Steam turns a turbine. The turbine turns a generator. The generator produces electricity. So all of these transformations occur in a power plant, and these power plants are the places that actually create our electricity. They burn fuel and they create our electricity. And so, with your green marker in hand, energy transformations occur when energy changes from one form to another. Okay, so like what happens down here in this power plant. And a main component of energy transformations is mechanical energy. And we understand that mechanical energy is when energy causes mass or matter to move. So, wind blowing is mechanical energy. The turbine turning is mechanical energy. If you see something moving, then it has mechanical energy. There are even things you can't see that are moving that have mechanical energy, like sound waves. Okay, so get your blue colored pencil and we'll just get the main ideas noted here. So the thermal energy or heat from burning can be transformed into mechanical energy, then into electrical energy by power plants. And this is where the majority of our electricity comes from. So the fuel that is burned is one of the main topics of this whole study on energy, and the burning of fossil fuels versus the burning of alternative energy fuels, or alternative fuels that are renewable. So so this is a little flow chart that I showed you a little while ago, and electricity is produced in the power plants. The power plants put the electricity out onto the grid. The energy grid is a huge collection of electrical poles, switching stations which have lots of different electrical components that modulate electrical power. High voltages are coming out of power plants. We're talking like really high voltages. So high voltages coming out of power plants and going onto the power lines, and then actually between the power lines and our homes or businesses, the electricity is treated or modulated or damped down so that it can be transformed down to lower voltages so that we can use it in our homes. And in our homes, basically, most of our appliances run off of 120 volt receptacles. There are some devices in our homes that take 240 volts, like our furnaces, our air conditioners, our oven, if you have an electrical oven. But most of our appliances, like fans, lights, lamps, most of the devices in our homes use 110 volts. So this is just as we're thinking about this, the beginning of this reading on alternative energy sources. The main issue here is, how do we get electricity? This is the main issue. How do we get electricity? And currently, and for years and years, the cheapest, easiest, most convenient way to produce energy has been to burn fossil fuels. Coal, fuel oil, and in some cases natural gas. Primarily, coal is firing our power plants, primarily. So mark a paragraph, make sure you get any notes here, and we'll take a look at paragraph 2.